Hello everybody, welcome to a Henstitute help session. So this one is the very first Newton's law problem. And it sounds weird because it looks like we have enough to find stuff about the airplane, but then you're asking what is the net force on the pilot? And you're like, I don't understand. Now some people just go, isn't it the same net force that's on the airplane? But if I had a force of 3.7 times 10 to the fourth newtons, that would be 37,000 newtons pushing on me. That would be a huge amount of force. Even though it's a 5-to-1 ratio between newtons and pounds, you're still talking about almost 10,000 pounds of force. That's a lot. So that's not what's happening here. What's happening is if the pilot is in the airplane, so here is our airplane, and our pilot is somewhere in here. There we go. If the airplane is accelerating forward, then the pilot is accelerating forward the same. So the acceleration is the same. So what we could do is we could say, I know acceleration is force divided by mass. And so the acceleration for the plane should equal the acceleration of the pilot, which would be their force divided by their mass. So this would be for the plane. I'll put A's on here for airplane. And this is pilot. So really what we can do is set up kind of a ratio of forces and masses. So I know that the force on the plane is this number, this 3.7, so that could go in here. 3.7 times 10 to the fourth newtons. And the mass of the airplane is the 3.1 times 10 to the fourth kilograms. And so we could actually set that up. And then over here, we'd have the force on the pilot, which is what we're trying to find, and then the mass of the pilot, which is 78 kilograms. So just do it as a ratio. You could actually find the acceleration of the plane, and that would be the same as the acceleration of the pilot, but I think you could just set them up as ratios. Hope that helps.